Evaluate the general antiderivative of x to the 3 halves times ln of x dx. Now notice once again we have a product of two simple functions. So if we prep this to have the natural logarithm of x, it would suggest a u dv integration by parts approach. The first term is algebraic, the second term is logarithmic, and so what we'd want to do is we would want to set u to be the logarithmic term, and we'd want to set dv to be the algebraic term right here. So let's replace those. U will become ln of x, and dv will become x to the power of 3 halves. Now we'll need the derivative of u, so we're going to have du dx is equal to 1 over x, or if we multiply both sides by dx, we'll have this differential here. And next we're going to need to go and integrate the differential of v. So we integrate both sides of this formula, and we're going to get v is equal to, let's see, we up the power by 1 to get 5 halves, divide by the new power, 2 fifths, and we have the formula for v. And so now we're ready to use the integration by parts formula. So take a look at what we've got here. We've got the integral of a u term times a differential dv, and integration by parts says that that's the same thing as the function u times the function v minus the integral of the function v times the differential of u. So we need to only substitute our terms in and see what we get here. Let's replace u by ln of x. Let's replace v by 2 fifths x to the 5 halves. So we have minus the integral. We'll replace v by the same thing, 2 fifths x to the 5 halves. And we'll replace du by 1 over x dx. And so now let's clean this up and keep going here. So the first term can simplify to 2 fifths x to the 5 halves times ln of x. And the second becomes the integral of 2 fifths, canceling the x's out, will leave me with x to the 3 halves dx. Oops, sorry about that. 3 halves, not 3 fifths, dx. Now we can go and integrate this last guy. So we're going to have a 2 fifths times x to the 5 halves times ln of x from the line above. Take away 2 fifths, the constant comes along for the ride, and the antiderivative here will be, once again, 2 fifths times x to the 5 halves. So we clean this up, we get 2 fifths x to the 5 halves times the natural logarithm of x minus 4/25 x to the 5 halves. There's one antiderivative, and here's all of them. You might notice that there's an x to the 5 halves in both pieces, so we could pull it out. And if we're going to go this far, yank out, let's see, a 2 that's common to the numerators, and a 25, which will clean up the denominators. If we pull this out, we're going to be left with a 5 times ln of x in the first expression. And in the second expression, we're just going to be left with a 2. So we can take this, add the integration constant, and here's another way of formulating that antiderivative. Either one is okay by me.